So I just stumbled upon this MCP Java SDK, and it's designed to help Java apps communicate with AI models. How cool is that?
Right? It's fascinating how it creates a standardized interface for such complex interactions. I mean, how does that even work?
Well, it supports both synchronous and asynchronous communication. Think of it like ordering food. You can either wait at the counter or get a notification when it's ready.
That's a great analogy, but doesn't that imply a level of complexity for developers? I mean, juggling both patterns could be tricky.
Absolutely, but it seems like they've thought this through. The SDK allows for a synchronous facade to keep things simple when needed.
Interesting. That sounds like a smart way to manage different use cases without overwhelming developers. But what about performance?
Good question. They use reactive streams for handling asynchronous operations. It's designed for scalability and efficient resource usage.
Wait, so does that mean it can handle multiple requests simultaneously without blocking? How does that even work?
Exactly through a concept called backpressure, it manages how much data can be processed at a time, like a traffic light controlling flow.
Wow, that's a neat way to visualize it. But I wonder, are there situations where this might not be effective?
You're right to think critically. While backpressure helps, there can still be bottlenecks if not implemented properly or if the system is overloaded.
That's a good point. And I noticed they chose Jackson for JSON serialization. Seems like a safe bet, but is it the best option?
That's interesting. Jackson is popular in the Java ecosystem, but there are alternatives like JSON or Moshi. It's all about what fits best.
True, but Jackson's familiarity might ease collaboration. Still, I'm curious about the decision-making process here.
They emphasize being pragmatic and interoperable, aiming to align with widely used libraries. Plus, they allow swapping out components.
That flexibility is crucial. But how do they manage observability in this setup? Logging and tracing seem vital for complex systems.
Great observation. They use SLF4J for logging, which is pretty standard in Java, and they have mechanisms for context propagation.
So this ensures that logging follows the async calls. That's smart. But it also raises a question about how easy it is to test.
Exactly. They have a shared testing module aimed at making it easier to develop and test in the SDK environment.
But what if someone wants to implement their own testing strategy? Does the SDK allow for that?
Yes, it seems they've designed it to be pluggable. You can integrate your testing tools without being locked into the SDK's choices.
That's a big plus. Now I saw something about client and server transport choices. They use JDK HTTP client, right?
Yes, using built-in libraries like that keeps it lightweight, which is a major advantage for developers looking for simplicity.
But won't some developers need more features from their HTTP clients, like advanced timeouts or different protocols?
You bet, they do provide Spring Web Client support as an option for those who need richer integrations.
Nice, but it's still a balance, isn't it? Keeping it lightweight while also being flexible enough for various needs.
Definitely, and the decision to keep the server transport neutral using Jakarta Servlet seems wise considering its widespread adoption.
For sure, it covers a lot of ground, but again, how do they handle authorization? I imagine that's complex.
They've left it pluggable, which allows developers to integrate their preferred authorization method. Smart move.
That makes sense. But it also feels like it pushes some responsibility back to the developers, which could be a double-edged sword.
Exactly, it empowers teams but also requires them to ensure security practices. It's a balancing act.
This project structure is fascinating too. It really allows for modular integration. I wonder how that impacts performance.
Good point. By separating concerns, they can optimize each module independently, potentially improving performance overall.
So if I just need core functionality, I can use just that module. That's super efficient.
Exactly, you can pick and choose what you need, but I'm curious about their plans for future directions.
Me too. Watching how concurrency evolves with the JDK could lead to some exciting updates, especially with virtual threads.
Right, it could simplify a lot of the current complexities. I'm excited to see how they adapt.
This SDK really seems to be paving the way for smoother AI integrations in Java applications. But I wonder about community contributions.
They actively encourage contributions, which is great for fostering a robust community, but will they manage it well?
That's a valid concern. Managing community input can be tricky. It'll be interesting to see how they handle it moving forward.
Definitely, the potential is huge, but so are the challenges. I guess it's a wait-and-see situation.
Exactly, but it does offer a solid foundation for building AI integrations in Java. I'm intrigued to see where it goes.
Me too, it's a thrilling time for developers in the AI space, especially with tools like this at their disposal.
Absolutely. I feel like we're just scratching the surface of what's possible with these technologies.
For sure, and it's discussions like this that really help illuminate the path forward. Let's keep exploring.
I can't wait. There's so much to dive into. Let's continue our journey into the future of Java and AI.